In this presentation, I'll introduce sustainable urban drainage systems. The presentation is structured in three parts. First, I'll start with the performance of land cover concerning rainfall. Second, I'll move to the main problems of conventional urban drainage systems. And finally, I'll explain what sustainable urban drainage systems are, their main principles and benefits. What happens in a natural ground cover when it rains? Well, in this type of surfaces, vegetated areas provide important functions for water management, since most of the rainfall is either evapotranspirated or infiltrated, and runoff is very low. However, in urban environments, impervious surfaces are dominant and vegetated areas are very limited. This map shows the percentage of green areas in a set of European cities. As you can see, in most of these cities, the percentage of green areas is less than 30%. What happens when impervious surfaces are dominant? In this slide, you have 4 scenarios, and as you can see, when we have a natural ground cover, 40% of the rainfall is evapotranspirated, 50% is infiltrated, and there is just 10% runoff. When impervious surface is between 10 and 20%, runoff is 20%. When impervious surface is between 35 and 50%, runoff increases to 30%. And if the percentage of impervious surface is between 75 and 100%, runoff increases to 55%. So, the more impervious surface, the more surface runoff there will be. But soil type is also important. As you can see in this table, faster infiltrating soils of type E, for instance sandy soils, have lower coefficients of runoff than lower infiltrating soils like of type D, like for instance clay soils. So, how is runoff usually managed in urban environments? Well, traditionally, surface runoff has been managed by using conventional drainage systems. These systems serve to gather up rainfall from impervious surfaces and remove them as quickly as possible. But they have several drawbacks. First, they are designed to accommodate relatively frequent events, and under extreme conditions, they may not have enough capacity to cope with the flows. This is especially worrying since climate change and global warming is bringing intense rainfall and rapid runoff. Second, when flows are low, these systems can often silt up, causing problems when the next storm arrives. And third, the amount of water infiltrating the ground is reduced by diverting the rainfall to the pipe system and depleting soils and groundwater and reducing flows in watercourses. So, as a response to this, an alternative way to manage surface runoff, or at least a complementary way, is increasingly being adopted worldwide. This system is called Sustainable Urban Drainage Systems, or SUDS. These systems tend to mimic natural drainage patterns through mainly natural elements and also artificial surfaces. Their main benefits are, first, the reduction of surface runoff, because they increase soil infiltration, but also silt removal and pollutant treatment, and water storage, which can be short-term or long-term. What are their main principles? Well, first, the reduction of impervious surfaces by using mainly vegetated surfaces, but also artificial elements like permeable surfaces, permeable pavements. Second, the division of the area to be drained into several subcatchments with different drainage characteristics and land use. And third, dealing with runoff locally, in other words, where and when it falls will be always the preferred option. Not only it will reduce the quantity of water to be managed, but also the need for conveying water of the site. And this was all about the introduction of sustainable urban drainage systems.